Hello, this is part 5 of the lecture Hypothesis Tests 2 in the QED module in Dev. And in this section we're going to try and be a bit more precise about what exactly tests do and don't tell us in probability terms. And here the language of conditional probability is essential because you're being given something, you're being told something which is the evidence of your test, and you want to know on the basis of that, or conditional on that, what's the probability of something else, your hypothesis. Now, what tests never tell us directly is the actual value of the probability that hypothesis is, the null hypothesis is true before we did the test. This is called the prior probability of H0. So even before you went and did all your testing, before you did that, what was the probability that H0 was true? So you never get that from the test. What you have got is alpha, and alpha is the probability of getting a reject result if H0 is true. That's what alpha is set up to be. And in symbols, we can write this as the probability of a reject result given H0 is true. That's what this line means, conditional probability. Similarly, the beta one is what's the probability of not rejecting it when H1 is true. So I'll be making that error. Unfortunately, even though alpha, which is the reject result, is giving us this, the reject probability is giving us this probability of reject given H0. What we want to know is this probability. What's the probability that H0 is true given that we got the result we saw? So either probability that H0 is true given we got a reject result, or probability that H0 is true given that we got a do not reject result. So given the result we got, what's the probability of H0? Conditional on that. That's what we really want to know. Now, remember the basis of all statistic tests is this, which you have a theory of the world in your mind. So maybe this is the null hypothesis, and you see some observations, your test results, and you want to know what the probability is given by the software or the calculation you do. You work out what's the probability of seeing this observation if this is correct. So that's what the universal tester gives us, the probability of the observation if the theory is true. So we've got probability of our observations given that the theory is true. What we want is to flip this round and get what's the probability the theory is true given that we've got these observations. In symbols, we want to know, for example, well, we do know the probability of a reject result if H0 is true. We want to flip it around and know that, okay, I've got a reject result, so what's the probability of H0 given that I've got that reject result? And flipping these things round, unfortunately, is not easy to do. Unfortunately, these two things are not the same, and they're often very different. The probability of reject result given that the hypothesis is true, which is alpha, that's not always the same as the probability that H0 is true given that you got that reject result. You can't just swap the things round. An example to try and illustrate this is that fairly realistically, in terms of figures, we can say that about 2 in 100 adult women are pregnant at any moment in time. If you take that figure, then you know that the probability that you are pregnant, given that you're a woman, is 2 in 100, assuming you have random selection from all the women. But the probability that you're a woman, given that you are pregnant, is more or less 1. So it's completely different. So you can't just switch those two things around. So, unfortunately, tests never tell us the actual value of H0, the probability that the null hypothesis was true before we even did the test, the prior probability. We have got alpha and we've got beta, which tell us these two conditional probabilities. However, if you've got a belief about the prior, or some way of estimating what that prior probability was, so the probability before you even did the test, and if you know both alpha and beta, then given all that information, you can calculate this exactly. What's now the probability of H0 given you've got your test results? Unfortunately, this is very rarely the case, and this means that test results need to be interpreted very, very carefully. You think carefully what they mean, and there's a lot of current controversy in literature about interpreting statistics results. A lot of that is based around people misinterpreting these probability results, and reading this as though it's telling you the probability that H naught is H naught is true given reject, whereas really what they mean is this, the alpha. So people just jumping from here to here. It happens too often. So don't be one of those people that makes that mistake. Be cautious and be happy. Thanks for watching.